The birth of the blockchain is generally considered to be the release of the Satoshi Nakamoto's Bitcoin paper in 2008 and the subsequent release of Bitcoin software in 2009. The invention of Bitcoin clearly was an important piece of work and provided groundbreaking advances in peer-to-peer computing. But that was just the discovery. In 1991, Stewart Haber and W. Scott Stonita invented the blockchain. Yes, you have listened it well. 17 years before the release of the Bitcoin paper, the main idea behind the cryptographically linking blocks in an append-only data structure was published in an academic paper. This work focused on timestamping documents, a popular use case for the blockchain technology. Even today, many businesses use this public blockchain system to notarize documents. Alright, in this video, we are going to learn what is blockchain technology. Blockchain is DLT, Distributed Ledger Technology, and is also called Secure Database. It is an accounting system where the ledger, means the records of the transaction, is distributed among the network of the computers. Blockchain is an immutable, distributed, decentralized, peer-to-peer ledger replicated across many nodes connected in a single network. That was the definition of the blockchain, and it covers this first step, what is blockchain. And in the definition, I have said many words like immutable, distributed, decentralized, and peer-to-peer. I will explain them separately as I wrote them here. First, let's move to the immutability. What is immutability in blockchain technology? In blockchain, there are lots of blocks that is peer-to-peer connected with each other. Each block has data, hash, and the hash of the previous block. Like this, they make a chain of blocks. That's why it's called blockchain, like the chain of many blocks. And each block has its own data. And let's suppose you change some data in a block. By doing this, you have changed the hash of the block. Because of this, the hash of this block is not valid with the next block. Because as I said earlier, block also contain the hash of the previous block. Now, if you also want to change the hash of the next block to match these two blocks, by doing this, now the second next block has not valid hash of this second block, and you will change these hashes next and then next and so on. And that's how blockchain is immutable. No one can change any data in the blockchain. If you want to change the data in the blockchain, you have to change the complete block. But you cannot change any data in the middle. If some hacker come in and try to crack the data, he will become mad after seeing the blocks because all the blocks are peer-to-peer connected with each other and each block contains the hash of the previous block. So he can't do any changes in here. That was the immutability of the blockchain. And now let's move to the distributed. How blockchain is distributed. As I said in the starting, blockchain is DLT. It means Distributed Ledger Technology, and all the nodes are connected in a chain. And the next is decentralized. Blockchain has decentralized network. In the decentralized network of the blockchain, no one has to know or trust anyone else. Each person or member in this network has a copy of the exact same data in the face of the distributed ledger. And there is no central location of the blockchain. The apps of the blockchain are simply called DApps, mean decentralized apps. And next is peer-to-peer or P2P. There is some history of this concept. Like this concept was introduced in 1999 when a college student Sean Finning created a music sharing service, Napster. That service quickly became the hub for the unauthorized of copyright songs, but 2 years gone, Napster was shut down by the lawmakers. As a result, this gave rise to the new generation of P2P services wanting to fill the void and further the development of decentralized networks. Today, the P2P or peer-to-peer model is leveraged in the web search engines, online markets, many streaming platforms, P2P blockchains, and IPFS protocol. Peer-to-peer network is decentralized communication between two peers. It's also known as nodes. They communicate with each other without need of the central server. And that was the history of the peer-to-peer, that how this concept introduced and what is peer-to-peer network. And the next is kinds of developers in blockchain. In the blockchain community, we have two kinds of developers. The first one is core blockchain developer and the second one is blockchain app developer. The core blockchain developer simply creates the clients of the blockchain like Bitcoin, Ethereum, Cardano, Solana, and many clients. But 90% of the developers are blockchain app developer. They create the apps on the already existing blockchain. The DApp means decentralized apps. This kind of applications are not hosted by any central location but they are decentralized. It means people has access to their node. And next step is companies use blockchain technology. There are lots of companies are using blockchain technologies, some of which are Microsoft, IBM, Oracle, Intel, Accenture and many more, as blockchain is the future of upcoming years. And now let's move to the practical to show you some practical work of blockchain, that what are the hashes, what is real block and how they are connected in peer-to-peer networks. If you remember, in starting I have told you if we change data in a block, the hash of the block automatically change with the data. So let's do some practical. That's our hash SHA-256 hash. Hash is of 256 bit and there are 64 characters in this hash. The hash of this empty data is this hash. Let's see if I add some data in here. For example, I type something in here. Let me type eTechViral. You can see if I type a word, the hash automatically changes when the data comes in. I typed A, you can see data has changed. If I type L, data has changed. Like this, with the increase of every single word, the hash will be changed. But the length of the hash will not be changed. The length of hash is fixed length and that will not be changed no matter how much data we put in this data field. You can see I'm pasting it continuously and the hash is changing but its length is not changing. And that was hash. A hash is a function that meets the encrypted demands needed to solve for a blockchain computation. And that was the hash of the block. And now let's move to the block. What is block? And that is the structure of block. You can see on the window. Block, that's the number of the block. Nonce, the nonce is nothing but an abbreviation of the number that will use only one time. Like this empty data has this nonce. If I change the data and mine it, the nonce will be different for this data. And this hash, the combination of these three things, block, nonce and data. And look at the hash. We have 40 in starting of the hash. If I type some data, you can see now the hash is not started from 4 zeros but it is started from DB4F7BC59 and some hash. And the background of the block become red. So for that we will mine it. It will take a little bit time. And now the nonce is changed. The hash is also changed. And that is our single block and there are this kind of data in the block. And let's move to the blockchain, means the chain of many blocks and that are connected in peer-to-peer network and collectively make a chain. On the window you can see we have about 5 blocks in here. Each block has the number of block, nonce, data, previous block hash and the hash of the block. We cannot change the previous hash of the block and the hash of the block that are blocked, but we can change the data, and you can see practically this hash is the previous hash of the second block. This hash is the previous hash of this third block, and so on. If I change some data in the first block, I type 1, 2, 3. You can see the hashes are changing. I changed data in the first block and its hash also changed. Now this hash is not valid with the second block. That's why its background become red. Let's remove again this data from here, and now it's perfect. And that was the practical to make things more clear to you. And that's it for the video. If you found this video helpful and want more videos like this, hit your thumb on the like button and leave a comment if something is not clear to you. For now, goodbye and see you in the next video.